Welcome to the chemistry lab. Today we'll be doing the thermodynamics of the complexation of cobalt. Boy, was that a mouthful or what? Let's get started, shall we? So, here we are in the balance room. We're looking to measure between 0.25 grams and 0.35 grams of the cobalt chloride hexahydrate salt, which should really be called aqua cobalt 2 chloride. But what the hell, who cares? We'll be working with a beautiful red salt. We'll measure again between 0.25 grams and 0.35 grams. Let's get to it. So, I've placed an empty 50 milliliter beaker onto the analytical balance. Its mass, 29.6621 grams. I have added about 0.3 grams of the cobalt chloride hexahydrate to my beaker, resulting in a new mass of 29.9630 grams. This will be, of course, the sample transferred into the 50 milliliter volumetric flask. At my workbench, where I have the beaker containing the roughly 0.3 grams of cobalt chloride hexahydrate, I've obtained from the fume hood my hydrochloric acid. Take note of the concentration. This will be important to us. 5.037 molarity hydrochloric acid. I will dissolve the cobalt chloride in the hydrochloric acid, and of course this will be done to the volume of 50 milliliters in a volumetric flask. I could technically pour the acid directly into the beaker, but that's poor technique. Proper technique would dictate that I pour the acid into a different beaker, and then pour from that beaker into the sample containing beaker. I'll partially dissolve the cobalt chloride in acid and then transfer it to the flask. And I'll repeat this process of rinsing the beaker and transferring, rinsing and transferring, rinsing and transferring several times to ensure the complete transfer of the cobalt salt into my flask. Let's get to it. Let's take a look at that color. Wow, a bluish pink. Pink from the presence of the aqua cobalt 2, bluish from the presence of the tetrachlorocobaltate 2. Good times. Let's keep swirling. Some students prefer to use a spatula to stir. Other students will straight up put their fingers in the solution, which is just crazy. Me, I'm a big fan of swirling to dissolve my sample. That way nothing touches my solution and it stays relatively pure. Good times. With the sample dissolved, I transfer it into the flask through the use of a funnel. dropper. As you know, when it comes time to use a volumetric flask, it's critically important not to add a solvent beyond the calibration mark. In fact, what you're looking for is the bottom of the meniscus to be lined up with the calibration mark. Now, if you'll excuse me, I can't hold the phone and do this at the same time. This kind of work requires skill. Momentary pause. Boop, 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 boop. Okay, as you can see, I've filled the flask to volume, 50 milliliters volume. And now I begin the process of repeatedly inverting the flask. Right side up, invert. Right side up, invert. Right side up, invert. And I'll do this for at least a few minutes. And you can be thanking me later for not having to watch me do this for the next few minutes. And here are the different baths produced by Mr. Fraser. A bath at 70 degrees Celsius. Whoa, walking's hard. A bath at 60 degrees Celsius. A bath at 50 degrees Celsius. And in final, a bath at 40 degrees Celsius. I will, of course, take the time to record the actual temperature of the bath from the thermometers which have been placed into the bath. Recording the temperature, of course, to the 10th place, as we all know needs to be done. In the meantime, however, as these warm up, I'll calibrate the spectroviz probe and obtain the absorption spectrum, which I would associate with each of the two complexes that are present. So, I've taken the time to fill a cuvette with the cobalt-2 chloride solution, which was prepared by dissolving the cobalt chloride hexahydrate into 6 molar hydrochloric acid. And because we dissolve the salt into an acid, we'll use the same acid, or hydrochloric acid, as the blank. So let us now begin by preparing the spectroviz probe. The process begins by, of course, tapping the screen and selecting Calibrate. It'll take a dark sample. We'll then want to wait the 90 seconds for, of course, the warm-up. Wow, I don't know about you, but it sure felt like those 90 seconds just flew by for me. We're now ready to finish the calibration process, and so I'm going to place into the spectroviz probe the approximately 5 molar hydrochloric acid, or solvent. I was sure to wipe down the cuvette prior to placing it into the spectroviz probe. I'm going to go ahead and select Finish Calibration, and it's done. We hit OK. We're now ready, of course, to obtain the absorption spectrum for the mixture of our complexes. How exciting! Tell me, does this look exciting or what? So, I take the sample containing the cobalt complex mixtures, I place it into the spectroviz probe, and with the mode currently reading full spectrum, I push play. There it goes. Waiting. Oh, wow, would you look at that? Let me go hit stop and we'll get a close look. Hit stop. There we go. It'll rescale. That's just gorgeous. Let me get that close up for you. 1 second. Very cool. So let's see. Stop being blurry. Stop it. You silly computer. Let's see. You need to sketch this in your notebook. Here we go. You want to sketch this spectrum in your notebook. I know you can't really read the numbers because it's all kinds of blurry, but the wavelength range runs from 380.4 nanometers to 899.4 on the far right side. Tell you what, let's figure out the absorbance wavelength for those maximum peaks. Oh, the shaking. Damn that airplane glue. So, this is when the fun begins. So I'm going to start by clicking on the meter button. I'll change the mode to events with entry. I'll discard the data. We can see it's already at 691.5 nanometers. If it weren't, however, I could always change the wavelength. But of course, we're already there, so why bother? Currently, at room temperature, we have an absorbance of 0.076. Well, the 40 degrees Celsius bath wasn't working properly, so I cranked it up to 80 degrees Celsius. And even though I've waited many minutes for something to happen, not much has happened. In other words, the temperature didn't rise very much at all. The temperature in the 40 degree bath is actually closer to 29 degrees Celsius. I know you can't read that, but what the hell. Let's just pretend you could. You would see that it's about, well, let me see for you. Yeah, I saw about 29.8 degrees Celsius. But that's good enough for us. Whoa, there it is. It's crystal clear. Do you see it now? About 30 degrees Celsius even though it should be closer to 80. Whatever. All we need is a temperature. And then we measure the absorbance of the solution. Cool beans. So, here I have my sample completely immersed in the water bath, which is at a temperature of about 50 degrees Celsius. While it's equilibrating, let us take a moment to record the actual temperature. I know you can't see that because my phone stinks, but that's looking a lot like 53.2 degrees Celsius. So record that in your notebook, 53.2 degrees Celsius. There it is. Score. If you can see, the sample has begun turning a purplish color. There's the sample. It's obviously changed color from pink to purple. It's been about, well, at least a cool minute in the solution. And so now is a good time as any to take out the cuvette, wipe it down to remove any excess water, and then quickly place it into the SpectraVis probe to record the absorbance. Are you ready? I'm ready. Let's rock this Casbah. So here we have our sample in the next water bath, which has a nominal temperature of 60 degrees Celsius. The actual temperature, which you may or may not be able to read, be happy to do it for you, is 63.2 degrees Celsius. Good grief, phone. Get it? Get it? Find it? Well, take my word for it. 63.2 degrees Celsius. And you can see the solution is definitely turning a darker blue now, far from the pink color we started with. We'll let it sit in this water bath for a minute or two longer, and then of course we'll take the absorbance at the maximum wavelength of 691.5 nanometers. Good stuff. Okay, so now we have our sample in the last of the 4 temperature baths, the bath at 70 degrees Celsius. The actual temperature will tell us again, although it hasn't worked for us yet. Nope, still not working. Damn my phone. Well, the actual temperature is 71.8 degrees Celsius. Again, 71.8 degrees Celsius. We'll remove the sample, we'll dry it off, and quickly place it into the Spectrovis probe. Wow, look how dark blue that is. A great example of Le Chatelier's principle in action. Increasing temperature, shifting to products. Super score. All right, here we go for the temperature. Oh, my bad. The absorbance. Look at that, crystal clear.